Hey guys and girls, here it is. Guitar number 50. Oh, 50. What am I doing? Guitar number 85. I was about to say 58. Guitar number 85 is complete. It's finished. It has the finish on it. Here, I'll give you a little preview. It sounds effing fantastic, and I really mean that. I actually don't say that about every guitar I build. So if I'm notoriously silent on a guitar, meaning I don't talk about it too much, then maybe that one was a little bit of a dud. But this one I will be talking about for a while. I'm gonna try not to talk too much right now though. Anyway, I'm gonna save my thoughts on the final product here on this actual guitar for the end of this several part series of videos that I'm going to do, which is going to document this entire build. And at the end I will talk more about my thoughts on the actual end result, and I'll talk more about what's going on with the tuners and some of the other new and interesting aspects of this build right here. If you are interested in this specific guitar, I will be selling it online on my website. You can check that out. There will be a link somewhere in the description. Also, if you are interested, I teach an online course on guitar building called Building an OM Acoustic. There will also be a link in the description for that video course if you want to learn the art of guitar making from me and build guitars like these. Furthermore, I teach a hands-on workshop. I just finished my spring workshops, and there are actually 2 spots still available in the fall workshops for 2022. They might be filled up by the time this whole video series comes out though. In that case, check out the 2023 schedule for workshops. Anyway, that as well will be in a link in the description. So, without further ado, we're going to now go back in time to basically the depths of this last winter, which is when I started this project, and I'm going to take you through and commentate on the progress as we go of building this guitar right here. Alright, I'm going to play you guys out. I don't know what I'm going to play. I guess I'll just strum around. Hey guys, it's a beautiful morning here at the shop in winter. So it's about as beautiful as it gets in winter with everything being dead and all that. But hey, the sun is shining and I'm about to get started with a new guitar build. Here I have everything laid out on the table. So the first thing I want to do is just take you guys along to talk about the various parts as I have them prepared right now. Let's check it out. Okay, so every build has a starting point. It's sort of arbitrary, but this is what I like to often consider as my starting point here, especially when you're filming the build, rather than taking you guys along the ride for all of the rough milling early steps. And what I like about considering this the starting point is that also all of the decisions, the aesthetic decisions, the dimensions, the wood choices and things like that, they've all been made at this point, so I don't have to second guess or doubt myself. I can just build. I can just get started. And as you can see, some things are much further along than others. The bridge, for example, is basically done. This is a new design, by the way. Very excited about this. But then other things like these brace blanks are just strips of wood, so there's a lot we'll be doing to those. Okay, so let's start over here on the end. The back is Ziricote, the top is Redwood, and they're already joined and thicknessed. I will be doing lattice bracing for the back, so that's different from your typical ladder bracing, which is by far the most common type of bracing that you see on a steel string acoustic, where the braces just run straight across, kind of like railroad tracks. In this case, the braces will be crossing at angles, and I'll have to cut lap joints to join those braces. Of course, we'll get more into that later. Ebony binding, I've already bent them. I've also already bent the sides, which is also Ziricote, obviously to match the back. Doing Port Orford Cedar for the neck because I've done this before. It's extremely light. It has a great stiffness to weight ratio. It's very stable, and I've had great experience with it before. So we're going to be doing the Port Orford Cedar again on this build. Let me also mention that it smells fantastic. So I got to admit that is also going through my mind when I'm making the decision on what wood to use. This wood is just very pleasant to work with. I enjoy it. Okay, this will be a 000 build. So a 000 is essentially an orchestra model size, but with a short scale length, 24.9 inches, as opposed to the long scale, which is typically 25.34 inches. This is just an end wedge piece right here that I've selected. I'm going to be doing Western Red Cedar for the braces, maple bridge plate, very standard, mahogany blocks, your neck block and your tail block, also very standard, mahogany kerfing, and then I'll be doing some pearl actually for the Rosette and also for the purfling, which is new to me. I've used pearl a lot, but I have not used it to make either purfling or Rosette elements. So that'll be cool. Okay, and that's sort of a quick overview of the parts. Let's go ahead and get started right away. I'm starting out working on the rim set here as I place it in my trusty vise. And the first thing I need to do is add the two blocks that are going to connect my two pieces of the sides. These blocks, the neck block and the tail block, need to be sanded in order to conform the mating surface. The mating surface of the tail block, which you see me working here, has a slight continuous curve to it, which is why the sanding board that I'm using actually has a slight dish into it as well, which matches that curve at the tail block area. Preparing the neck block for gluing is even simpler because I just need a flat sanding board. The neck block area is flat rather than a continuous curve. So I pull out my flat sanding board and I'm going to progress through the grits so that the mating surface is both flat and smooth and ready to be glued. When I'm attaching the neck block, the first thing I do is dry fit the workpiece. The purpose of this is to align the block with the center line of the mold and then place 4 reference blocks to lock its position in. These blocks are simply pieces of scrap wood with double stick tape attached to them. And the point of placing these reference blocks there is to make the glue up far more secure and simpler, because when I add that glue, it's going to act as a lubricant and it's going to want to swim the workpiece all over the place. And it would be very difficult without these reference blocks to keep yourself on center. We want to avoid glue creep. And while the glue cures on those blocks, we're going to turn our attention to something else entirely.
the bracing stock needs to have the mating surfaces radiused to match the radii of the plates. So I'm starting with my soundboard braces first. The soundboard is going to have a 30-foot radius. Typical soundboard radii range from around 28 feet to 40 feet. The larger the number, the flatter the radius, by the way. So the idea here is that I'm going to sand a radius into the mating surface of these braces using a concave dish here called a radius dish. Now, guitar plates are very thin and pliable, so the idea is if I sand this radius into the mating surface, then when I glue it down to the top or to the back, those plates will be thin and pliable enough that they will get pulled into whatever doming I put into the braces. And I've got a lot of soundboard brace blanks to get through here, so I'm just going to put some good music on and plug away at it. Here I have two other dishes with progressively finer grits of sandpaper on them. So here I'm just simply progressing through the grits so that we not only have the proper radius on each brace, but the mating surface is also smooth for glue up.
Alright, and now I'm going to swap out this dish here, this 30-foot dish that we just used for the top, for a 12-foot radius dish for the back. The back is going to have a different radius, a 12-foot radius, from the top. And that's because we don't have the additional complications on the back of the fretboard tongue and the bridge and having to deal with gluing those down. So we can afford to have a greater curvature on the back. And the more curvature means the less structure is necessary to keep that plate structural. So we can afford to have less mass on the back plate if we give it more of that doming. Now with the last set of braces for the top, I just went straight to the dish and started sanding. However, in this case, because the curvature is so much greater, what we're going to want to do first is actually mark the contour onto the side of the brace and then just pre-carve that away a little bit, just in the interest of time. Alright, now we're going to take this to the dish and finish it up. So I'll just mark up the bottom. And sand until the marks disappear.
Alright, with the back braces all radiused and ready to go, I can now assemble my lattice bracing. So what I need to do is dry fit these braces in order to mark out places where I'm going to cut a series of overlapping notches. These overlapping notches will form what are called lap joints. So first I just place the two bottom braces in the go bar deck, and I'm going to place little reference blocks, just like we did for the tail block and the neck block. I'm going to place those reference blocks to hold the position of these bottom lattice braces. Now I take the other two braces, which will be the overlapping part of the lattice, and I'm going to align them with my outline and then just simply mark along the side of each brace to get the locations for my notches. Alright, now I'm ready to cut these notches in my nut slotting vise, which is just a really nice, convenient vise for making small cuts like this. I use a straight edge, a square, and a marking gauge to draw out the full box of the notch, basically to mark out where all of the waste material is to be removed. And I actually like to use a nut seating file here, a StewMac nut seating file, to cut these notches because the 1/4 inch nut seating file just so happens to be just a hair undersized for my 6mm wide bracing blanks. So I can get a really tight fit using this file. Otherwise, a Dazuki saw and a nice sharp 1/8 inch chisel is a great way to pop out these notches. Alright, let's go back to the Go Bar deck so we can assemble things again in order to mark out the corresponding notches in the other brace blanks. And in similar fashion, I cut the corresponding notches. Okay, so I have it fitting very tightly here, but this is the point where I want to take this out and flip it over, and I want to check that all of these seat all the way down. And so you can see there's a little bit of a lip here and here, and a little bit of a smaller lip here and here, and I can fix those by simply popping this out very carefully. This is extremely tight, and you can actually snap something here. So I'm going to put this down as I carefully work it out. Okay, and all I have to do is, I'm just going to file a little extra depth to either the top one or the bottom one. It doesn't really matter. I could even just take a little off of each one if I wanted to. I'm going to go ahead and file a little more depth into these ones right here because they look like they could be a little deeper. And then you just take this and we're going to pop it back in. You can really hear how tight that is, which is a good thing. Okay, that's seated all the way in, I mean as far as it can go. And there's still a little bit of a lip, so I'm going to pull that out and do it one more time. And I'm just going to keep doing that to both of these pieces until I no longer have that little lip. Lastly, I give the whole unit a light sanding on the radius dish, which just corrects any sort of discrepancy that I have between the angles of the mating surfaces of the top braces and the lower braces. If the top braces are angled slightly in their notches, then they won't seat as well as the lower braces. Sanding this in the dish cleans that up. And as a final check here, I shouldn't be able to fit this thousandth of an inch feeler gauge here. Very, very small, the smallest feeler gauge I have. I shouldn't be able to fit that underneath either side of these bars if they're touching this surface. If they're still getting held up by the bar underneath, then they're going to be teetering on it, and you should be able to pass this under the brace. But here, as you can see, when I press it down, this cannot fit underneath. The mating surfaces are perfect, and I can glue this up in the go bar deck. Okay, so now that I have the lattice on here, this is really my modified version of a lattice bracing or a double X bracing. So I'm going to be modifying it by adding these two cross beams up here in the middle, one there and one over on the top side. And that way, if I were to just keep adding more lattice braces running across here, that would be a lot of structure that comes in and connects with the rims, and I don't want the rims to be super duper tight. So rather than filling in this space by running more lattice across, I'm going to simply add this connector brace up in here. And so the modified lattice bracing is installed. We'll let this cure for a little while. In the meantime, let's move back to the rim set and get some work done there. Once all the clamps from the previous glue up have been removed, I take the rim set over to the radius dish. And who loves sanding? This guy does. Alright, let's get back to the grind here. Back to more sanding. In this case, we are sanding the radius. Remember how we sanded that radius into the brace blanks? Well, we also need that same radius sanded into the surface of the rims, which is the gluing surface for the top and the back plates. We will do this same job a second time after the kerfing is installed, but this initial sanding is just to rein everything in close to its final dimension before we install the kerfing. That way we don't sand too much of the kerfing away later. And if you recall from what I mentioned earlier, the back plate has a different radius from the top plate. So now I'm going to swap out my dishes, put the 30-foot dish away, and pull the 12-foot radius dish out so I can radius the back side differently from the top. And then I install the kerfing along with the side struts with these modified mini C-clamps. After the kerfing is installed all the way around the rim set, I can take the rim set back to the radius dish for that final touch-up that I talked about, where we simply bring the kerfing, which is slightly proud of the sides, we bring it down flush with the sides, giving us a nice, perfect glue surface for the top and back plate. Alright, and so now we have the rim set completely ready. I've added the side braces, which just give rigidity back to the sides. They also protect it against catastrophic splits that would otherwise potentially run all the way across the side.
I've added the kerfing, which of course just gives us extra surface area, which is totally necessary for gluing on our back plate and our top plate. And then of course, this whole thing is radiused. The surface of the kerfing is radiused to match the radii that I've selected for my plates, which is 30 foot on the top and a nice dramatic 12 foot radius on the back. So the smaller the number means the more curvature that you get out of it. So that 12 foot radius is actually pretty large. All right, now with that said, let's turn our attention to the bracing that I've already installed in the back plate, and we're gonna have a real good time just carving out the tapers and the scallops into this bracing pattern. All right, let's get to it.
Carving the braces is one of the most cathartic and enjoyable aspects of the whole build process. The only thing that comes close, I'd say, is neck carving, which is also a joy. Recently I picked up these two cherries. They're actually marketed as guitar brace chisels, and just to try them out, and I do find that they're actually they make the process a little bit more enjoyable still, a little bit easier to carve with. My initial focus for the carving process is on the brace ends. The ends are all tapered down until they reach a uniform height at the perimeter. Later on, corresponding notches will be cut into the kerfing so that those brace ends can be joined with the structure of the sides. To get the scoops at the center of the lattice, I actually use a cylindrical object wrapped in sandpaper. You could use just a wooden dowel for this, but I actually like to use the core from my spindle sander because I have a variety of sizes, and there happens to be one that fits just right and gives me a very attractive scoop right at the center square of my lattice pattern.
Okay, so I just flattened the top of my bracing pattern here to create a nice flat plane, because at each one of these little X's, we are now going to install this itty bitty little cap here. This is just a piece of cedar, very thin, that is going to complete each one of these joints. And it'll look just like that when it's all glued down. Now, why am I doing this in the first place? And this is something that you typically do on an X brace at the center of the X, but the concept here is the same. We just have 4 different X's. So if you look at the joint closely, let's start with this piece here. This brace retains its full height all the way across these joints. However, the brace coming in at the opposite direction actually gets cut down to about half its size because of that lap joint. And so there's a possibility for weakness along this part of the brace and not along this side. So what these little caps do is they restore the full height by bridging over the top. So to make this pattern equally strong in both directions, we're going to add these little caps now. All right, let's do that.
And now I'm profiling the braces. So basically I'm taking the boxy, squared off appearance of the braces that we have right now, and I'm going to clean up the edges to bring that into more of a pyramidal, triangular shaped profile. Not only is this aesthetic, it makes them look a little less industrial as they do when they have that squared off look, but also, it's removing unnecessary mass from the sides of the braces. Remember how I mentioned that the brace ends were going to taper down to a uniform height? Well, I have a dedicated Dremel that is set to cut the brace ends to this specific uniform height. That way, every brace end is cut exactly the same, and later on when I cut the notches, I have a corresponding Dremel that will cut those notches to that same uniform height. That way I get no slop in my joints. And just some final touch-up work at the end here to blend in the area where I used the Dremel, the flat uniform height area, with the scoops of the braces. This is just aesthetic, and it's just a nice little touch at the end. So the modified lattice bracing I find to be, at least theoretically, a better bracing pattern than the go-to standard, which is simple ladder bracing. Ladder bracing, which is a bracing pattern where the braces simply run straight across like railroad tracks. Ladder bracing has the advantage simply of being the easiest bracing pattern to execute. So it's very time efficient, it's not very costly for that reason, and also it's easy for the beginner to execute without mistakes. This is a little more involved, of course, and the reason people don't go to a further extent than the ladder bracing on the back is honestly for a good reason, which is simply that the back, when compared to the soundboard, the top, simply has less of an influence on the overall tone than the top does. And it's pretty significant
how much the top affects the final output of the sound, and it's pretty trivial, arguably, how much the back affects it. So I don't necessarily fault people for defaulting to the ladder bracing, but this is a Lutherie channel. I like to have a little fun here. I know that this produces a better result, and I don't mind spending the time to do it, especially because I get to share it with you guys. And here we have the rim set, which is pretty much ready to go here. I've got the side braces installed. I have the kerfing installed. The only thing left to do really is to cut out the corresponding notches for the ends of my bracing here. And likewise, I'll do the same on the top side as well for the top bracing. And one thing you'll notice about the way I do the sides is I prefer to have the side braces run all the way across the width of the side rather than just running between the kerfing, which is fairly common. It's not going to make or break anything either way. I just prefer, for the sake of just durability and longevity of the instrument, to not have basically a weak point where right at that point where the side brace would meet the kerfing. Here we don't have that because the side brace actually extends all the way up through the kerfing.
Okay, back to work now. This is exciting. We're almost ready to glue the back plate down. But first, before we do that, we have to cut those corresponding notches into the kerfing that I talked about. That way, the brace ends can fit into the structure of the sides. Alright, once I've checked and double checked the fit at the notches and it looks good, we can go ahead and glue this bad boy down. Alright, the back is secured, and I think we've done a lot of work for this first video. We can pick up where we left off in the next episode of this series. Bye for now. If you learned something here, please give this video a like and subscribe so you can be notified when I release a new DIY guitar making video. And if you want to really learn more, take one of my structured online courses at ericschaferguitars.com or register for a hands-on guitar building workshop here with me in Burnville, Pennsylvania.